Hey everybody, so today's lesson is about vectors and scalars in physics. So these words, vector and scalar, are two classes or families of measurements or quantities in physics. So everything that we measure is either going to be in the family of scalars or in the family of vectors. So it can't be both, it's going to be one or the other. It's either a scalar or it's a vector, and we're going to put them into their classes, okay? So a scalar is any measurement or quantity that is fully described by a magnitude alone. And you'll notice that I made that word magnitude in all caps there because it's a really important word in physics. So when we talk about the word magnitude, we're talking about how much or how big or how strong of a measurement you have. All right, so for example, if we were measuring the weight of an object and we're talking about what's the magnitude, that's how much weight. All right, if we're talking about the magnitude of a force, we're talking about how strong of a force are we talking about. If we're talking about displacement, how big of a displacement. So it's how much of whatever it is you're measuring. It's the number part of a measurement, okay? And then a vector is any measurement that's fully described by both a magnitude and a direction. So the key difference here is that scalars don't have a direction and vectors have direction. So in order to fully describe that measurement, you need both an amount and a direction. Okay, so for example, a force, and I'll go into a slide in a minute with some more examples, but a force is an example of a vector quantity. And the reason for that is force has an amount, how much or how hard do you push or pull, but also what direction do you push or pull? Are you pushing to the right? Are you pulling to the left? Are you lifting an object upwards? Force has a direction, okay? Whereas something like, let's say, length doesn't have a direction, all right? We measure that amount, but you can't say like, oh, the object's length is, 2.2 meters to the east. Like that doesn't make any sense, right? So length is a scalar quantity, whereas something like force is a vector quantity. So if it has an amount and a direction, it's a vector. If it has only an amount, it's a scalar. All right, so here are some examples on the next slide here. So I made a list. Here are some scalars. So length is an example. Weight is an example. All right, you can't say, well, I weigh 170 pounds to the north. Like, what are you talking about, dude? That's crazy, right? So direction doesn't go with that. Or time, temperature, mass. All right, these are all examples. Power, speed, distance. These are all examples of scalar quantities. They only have an amount. Of course, they have units, right? So we could say, 170 what? Pounds. We could say the temperature outside is 70 degrees Fahrenheit. So they have units, but they don't have a direction. All right. In the other column, we have vectors. And for vectors, we have things like position. I am 140 meters to the east of the origin. All right. Or displacement, my position has changed by this much in whatever direction. Velocity, we could say the wind is blowing at 10 miles per hour towards the south. All right. That's a velocity. All right, force of gravity or forces in general are vectors. Momentum is a vector because when things collide, it depends on what direction they're moving, and momentum is conserved in a collision, so momentum is a vector quantity. All right, so if they have an amount and a direction, we call them a vector. If they have only an amount, they're scalars. They have only that thing we call magnitude. So really not terribly different here, or difficult, I should say, not terribly difficult. We should understand the differences between these two. And really where we're headed with this is as we move into our unit on kinematics, on talking about motion. We want to try to measure motion as best we can using vectors. And the reason for that is because they have more information. If we talk about both an amount and a direction, we're going to be able to be a lot more specific than if we only talk about an amount. And we're going to see lots of examples of this in different things we do in class.